Hello students, I am Dr. Gajendra Purohit. I upload videos for engineering mathematics, B.Sc on my YouTube channel. If you are preparing for any competitive exam where higher mathematics is asked, my channel can be very helpful. I have uploaded a lot of videos on real, linear, complex and numerical analysis. Or if you are preparing for engineering mathematics, there are many related videos that I also have uploaded. You can find the link on IIT-JAM and in the description. There are several videos of differential equations and I'm uploading it again. I have already posted a lot more videos, so you can also check that out through the IIT-JAM. And today I am going to tell you about reducible to exact differential equations. How do we solve it and how do we find its integrating factor here? I am going to explain this. And the problem that students face here is that they don't know how to find the integrating factor. Today I am going to discuss two cases and I will discuss the two cases in the next class. So, if there is any differential equation given and it is not exact, right? We know that if any differential equation is given, let's say m dx plus n dy, this equation is given, and this is not exact. This means that del m by del y is not equal to the del n by del x. They are not coming equal. Then this equation is not exact. If it is not exact, so we can reduce it to an exact equation. Now to reduce it, we have different types of problems, and according to that, we have an integrating factor. If any differential equation is given that is homogeneous, it means that we can solve it by putting y equal to vx. The degree of all its terms should be the same. If that is the case, what we will get as its integrating factor? Its integrating factor is 1 upon mx plus ny. And if we multiply this integrating factor to this differential equation, then this equation will be reduced to an exact equation. And after that we can solve it. Let's take an example. I will try to explain. Now the question is given. If we talk about m here, you can notice here that its value will be x square y minus 2xy square. And now if we talk about n, its value will be minus x cube minus 3x square y. And if you will check the value of del m by del y here, what are we getting here? It is x square minus 4xy. And if we discuss about del n by del x, then minus is outside here and we will get 3x square minus 6xy. You can see that these two are not equal. This means both are not equal. This means this equation is not exact. So we will have to reduce this to an exact equation. We will calculate the integrating factor here. And its integrating factor is 1 upon mx plus ny. The value of mx plus ny that we have here. What will we do? We will multiply the value of this m by x here. And then we will get x cube y minus 2x square y square minus. Wait, this is a plus, but here minus. We will multiply with y. So we will get x cube y. And this minus and minus will be plus. If we multiply this by y, we get 3x square y square. And this term cancels out with this. It is minus and this is plus. Here we will get x square y square. And this value is the integrating factor. I'm sorry, this is the value we got. We will put it here. So the integrating factor we will get will be 1 upon x square y square. Now let's multiply this integrating factor with this equation. Now let me change the color so that you can understand things better. What will we do here? This value 1 upon x square y square. I will multiply this with this equation. And this will be x square y. Minus, it will be 2xy square. And dx here, right? And minus, we will get the value as x cube minus 3x square y. dy is equal to 0. Now, when we multiply this, x square cancels with x square. This will become 1 by y minus this y square cancels with y square. This will be minus 2 by x dx. And when we multiply this with this, x square will be cancelled. So this will be x upon y square. This x square cancels with x square. This will be minus 3 by y into dy is equal to 0. Now this has become m dash. We will consider this as m dash. Like I explained, if we multiply it, this will be reducible in exact. Right? So let's check once if this becomes reducible to an exact equation or not. We will consider this as m dash and n dash again. And now we will differentiate it with respect to y here. The derivative of 1 upon y is minus 1 upon y square. We will differentiate n dash with respect to x. It will be 0 and the differential of x is 1. This will be minus 1 upon y square when we multiplied with the integrating factor. Then this equation became reducible in exact. When any equation becomes exact, then what do? We directly integrate it here. It has a formula. If you haven't seen the video about exact equations, you can find the link in the description or in the I tab. We will integrate such a term where x is not present, but x is present here. So we will remove it and then this term will be left here. It will be minus 3 by y dy equals 0. Sorry, it will be c when we do its integration. 1 upon y is a constant and dx will be x. it will be x upon y minus 2 log x. Minus and minus will become plus. 3 log y is equal to c. What will we get here? This is the answer. In this way, this question can be solved. Now let's discuss further. Now students, if a given differential equation is not homogeneous, or if it is of this type, it means that y is common in m and x is common in n, and it's not exact. Let's take an example here. 1 plus xy multiplied by y dx here, and then plus this value will be 1 minus xy into x dy. This is the example. And we can notice here that the value of m will be when you multiply this term by y. This will be xy square and this is n, and we will multiply this by x. So it will be x square y here. You can notice here that when you will calculate the value of del m by del y, it will be 1 plus 2xy. And when you will calculate del n by del x, you will get the value as 1 minus 2xy. These two are not coming equal. This equation is not exact. But this matches with it. Here y is common and x is common from here. This means the integrating factor will be of this type. And this equation is not homogeneous. If it's not homogeneous, then we can't use that old method, right? So what will we do in this? First, we will find mx minus ny, multiply m with x. So we will get xy, right? If we multiply by x, we get plus x square y square minus ny. So we will multiply by y. This will be minus xy. Minus and minus will be plus. This will be x square y square, right? This xy will be cancelled. So this will be 2x square y square here. And students, what is the integrating factor? We know its integrating factor is 1 upon mx minus ny. This means it will be 1 upon 2x square y square. Now what will we do here? We will multiply by this. So multiply this equation by 1 upon x and to x square y square. We will multiply 2x square y square with this equation. First, let's simplify this by multiplying with y. This will be y plus xy square. Dx plus we will multiply this by x. This will be x square y into dy is equal to 0. In this, the 2 will become 0 because it's a constant. We don't need it. And multiply x square y square. So we will get 1 upon x square. Y? Y square will get cancelled, so plus 1 upon x. Dx, when we multiply this with this, x will get cancelled and this 2 has become 0, 2 is not multiplied. This will be xy square minus. X square will get cancelled from x square, giving 1 upon y dy. Now take this as m dash. You can take this as n dash, and when you take this as m dash and n dash respectively, then you may check. These two values will be equal. That means when you will differentiate this with respect to y, this will be minus 1 upon x square y square. You can check that. This equation will be reduced to exact. When it is reduced to exact, we do its integration directly. So here it will be directly integrated. Plus 1 upon x. And the integration of such a term where it is not x will be done. It means here minus 1 upon y. Dy is equal to this will be c. I don't have enough space here. So let me do one thing. Write it over there instead, right? And the integration of 1 upon x square is minus 1 upon x. Now the answer we will get here is minus 1 upon xy. In this case, the integration of 1 upon x is log x, right? And the integration of 1 upon y is minus log y equals to c. So what is this value we got? This is the answer. In this way we solve it. Now let's take another example to understand it better. Look here. When we have this kind of question given, this one is also the same like before. Here we will find the value of m. This y will be multiplied. This will become xy square sin xy plus y here cos xy. Sometimes students make the mistake of multiplying y with the angle, which is incorrect. So do not do that. This is n. We will multiply these terms and then here we will get x square y into sin xy minus x cos xy. So when you will check, when you will calculate del m by del y and del n by del x, you will find that these two will not be equal and equation is not exact. And when the equation is not exact, we will find its integrating factor. We know that integrating factor is 1 upon mx minus ny. I will calculate the value of mx minus ny here. So multiply m with the x. When we multiply this by x, then this will become x square y square into sin xy, right? Plus it is xy. And cos xy here. Minus multiply this by y. It will be x square y square sin xy, right? This minus and minus will become plus. And we will multiply this by y. This will be xy and cos xy. You can see here this term and this term are cancelling out. And students, what we will get here? It is to xy. And here cos xy. And what we will get as its integrating factor? 1 upon to xy. Cos y. Sorry, it will be cos xy, right? This will be its integrating factor. We'll multiply this equation by this integrating factor. Now let me write this equation properly, and I will use a different color so that you can see clearly. I will first multiply this by y inside, right? First of all, write the integrating factor. 1 upon 2xy. Cos xy, this 2 is not useful here, students. This will be 0, right? Don't write the constant. Multiply this with y and we'll get xy square. Sin xy, right? Plus, this will be left. So we will get y. Cos xy, and it will be multiplied by dx. And I will write the remaining terms here. When it will go inside, we will get xy, sorry. It will be x square y. And here we will get sin xy, right? Clear? And minus here it will be x cos y multiplied by dy here. Have you understood? Is equal to 0 here. Now multiply this. So x will be cancelled with x and y will get cancelled with y. We will get the value here as tan xy, and this will be y here, right? Y cancels out with y. This will give 1 upon x and cos xy. So this term becomes 1 upon x into dx here. When we discuss about this, then y will be cancelled with y here, and 1x will be left above. We will get x tan xy, clear? This cos xy will cancel out with cos xy. Here x will get cancelled out with x. Therefore, we will get 1 upon y into dy, right? And you can see that this value is n dash, this value is m dash. We'll find del m dash by del y. When we differentiate with respect to y, we'll get its derivative by u into v. Here we'll leave y and we will get tan xy, keep y as it is, and if we differentiate it, we get sec square xy here. What will come in denominator? We are doing it with respect to y. So here x will come, right? Sec square xy and here constant. Sorry, x will come in front because we are doing differentiation here. Let me do it again. Let's take m dash. Now differentiate it with respect to y. This will follow the u into v rule. Leave y as it is here, so we will get tan xy. We did y and left tan xy as it is, right? And if we differentiate this and leave y, this will give us x square xy. As we are differentiating with respect to y, so x is constant, it will be here. So in the same way, when you differentiate this with respect to x, this is what we get. You can check it, right? So both of them are equal and this equation is exact. Now this is exact. So we will directly integrate it. So it will be y. It is tan xy plus 1 upon x. An integration of such a term where it is not x will be done. But it is x here, so it will be minus 1 upon y. Into dy is equal to, it will be c. So students, see here what will be its integration. Now when we integrate this, then y, and this will be our log sec of xy, right? And since we are differentiating with respect to x, y is constant, it will come here. Here integration of 1 upon x will be log x. Minus log y is equal to, let's take a constant c here. So this y will cancel out with y. We will get the value as log sec of xy plus log of x minus log of y is equal to, it will be c here. This is the answer we will get, and in this way we can solve this question here. And this question is for the comment box. There are 4 options given here and you have to find out what will be its integrating factor. Tell me the correct option. How many seconds did it take you to solve it? Do tell me in the comment box. And how are you liking this series? Let me know. You can watch all my videos here. The complete differential equation playlist is available now. And I've uploaded many videos on my new channel where I'm uploading some useful short tricks. From here, check out my new channel. You can subscribe to it there and you can follow me on Instagram. Thank you so much for watching this. Like it, share it and subscribe to the channel. Please tell me the answer in the comment box. Thank you.